Hello friends, today we will study about the problems in wave theory of light. Let's see the first problem. Here in this problem we need to find the velocity difference between the rays for the two colors in water, namely red and violet. So the problem is the refractive index of water for red and violet colors are 1.325 and 1.334 respectively. Now we need to find the velocity difference between the rays for these two colors in water. So here we have given the refractive index for red color in water is 1.325 and refractive index of water for violet color is 1.334, and the given is here Vr is velocity of red color in water and Vv is velocity of violet color in water, and we need to find the difference between the rays for these two colors in water, that is Vr minus Vv, that is delta V. So as we know the formula, that is Vr is equal to C upon mu W, where C is the velocity of light and mu W is the refractive index of water for red color, and Vr is the velocity of red color in water. So we have given C as 3 into 10 raised to 8 meter per second, and mu W for red color is given as 1.325. So on dividing 3 into 10 raised to 8 meter per second by 1.325, we will get the value for Vr, that is velocity of red color in water, as 2.26415 into 10 raised to 8 meter per second. Now we will find the velocity of violet color in water. It is given by the formula Vv is equal to C upon mu by V, where C is the velocity of light and mu V is the refractive index of water for violet color. It should be mu V. Therefore, you can see that Vv is 3 into 10 raised to 8 meter per second divided by 1.334. So on dividing 3 into 10 raised to 8 meter per second by 1.334, we will find the velocity of violet color in water as 2.2488 into 10 raised to 8 meter per second. So on subtracting equation number 1 from equation number 2, we will get delta V is equal to Vr minus Vv, that is equal to 2.26415 minus 2.2488 into 10 raised to 8 meter per second, that is 0.0153 into 10 raised to 8 meter per second. So the velocity difference between the rays for these two colors in water, that is delta V, is 1.53 into 10 raised to 6 meter per second. Thank you. Okay, now we will see the second problem under the chapter wave theory of light. In this problem, we need to find the wavelength of violet light in glass. So the problem given as the red light of wavelength 6400 angstrom in air has wavelength 4000 angstrom in glass. If the wavelength of violet light in air is 4400 angstrom, what is its wavelength in glass? So the given is wavelength of red light in air, that is 6400 angstrom, and wavelength of red color or red light in glass as 4000 angstrom. We have also given wavelength of violet light in air as 4400 angstrom. So here the hint is, assume that the refractive index for red color is equal to refractive index for violet color. So now we need to find the wavelength of violet light in glass. That is lambda GV. So as mu R is equal to mu V, it can be written as wavelength of red color, red light in air divided by wavelength of red light in glass equal to wavelength of violet light in air divided by wavelength of violet light in glass. We have given wavelength of red light in air as 6400 angstrom, wavelength of red light in glass as 4000 angstrom, then wavelength of violet light in air as 4400 angstrom, and we need to find wavelength of violet light in glass. So on cross multiplying 4400 by 4000 angstrom and dividing 6400 here, you will find that wavelength of violet light in glass is 2750 angstrom. Thank you.